Good morning, dear students. Welcome back to my YouTube channel. And it is today once again I will take up definite integrals topic in that part 7. Here I have written a few reduction formulae and 4 formulae I have written. Kindly go through this. Watch the video carefully and please commit these to memory. I will explain. Say if n is an even natural number, then integration from 0 to pi by 2 sine power nx dx is equal to n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on into pi by 2. It should end with pi by 2. And numerator, see, there should be all odd numbers. 1, 3, 5 and so on. Denominator, there should be all even numbers. Like first n minus 0, 0, 2, 4 and so on. It should end with pi by 2 if n is even. If n is odd, then question is same. So integration from 0 to pi by 2 sine power nx dx. But answer is same again, beginning the product in the same way, n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on into finally it should end with 1, not pi by 2. Now third one. Question is integration from 0 to pi by 2 cos power nx dx provided n is even. If n is even, formula is same as that of first one. See, n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on into last it should end with pi by 2. And if n is odd, the fourth case, then integration from 0 to pi by 2 cos power nx dx is equal to same as the second one, n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on into 1. Therefore, this reduction formula I would like to consider as a short trick 1 in this definite integrals part 7. Let us consider this as short trick 1. So watch the video carefully and commit to memory this formula, and I will solve the exercises using this formula now. Dear students, now I would like to solve a few exercises using the reduction formula. Observe the video carefully. For example, first one. See, lower limit is 0, upper limit pi by 2. And it is, n is 10. 10 is even number. Sine power 10x dx. So, if it is even number, first ratio, n minus 1 by n is 10 minus 1 by 10 into n minus 3, 10 minus 3 by n minus 2, 10 minus 2 into 10 minus 5 by 10 minus 4. Like this I have to keep on writing. But I can reach in the numerator till 10 minus 9. I cannot go to 10 minus 11. I cannot have a number more than 10. In the denominator also I can have maximum 10 minus 8, not 10 minus 10 possible. Therefore next term I will continue writing. It is 10 minus 7 here. Divide by 10 minus 6. Then there is 10 minus 9. Divide by 10 minus 8. And here only into, now there is nothing to write dot etc. So since this n is even 10, we should end it with pi by 2. So this product, if I could simplify, so this is 9 by 10, this is 7 by 8, and into this is 5 by 6, and this is 3 by 4, this is here 1 by 2, into finally pi by 2. And of course, this one can simplify, and that simplification is, or simplified form is our answer. I'll just pause here for a while and you kindly simplify this. The 5 thing, you're done. 3 here with the 6, 2 times, 5 with the 10 here, 2 times. And numerator is 9 into 7, 63, and this 5 remains. Pi upon. This here, 2 into 8, 16, into 2, 32. 32 into 4, 128. 128 into 2, 256 into 2. So 512. So this is the final answer. I would like to take up a second example where I will take same limits. I cannot change the limits. Integration from 0 to pi by 2. But I will take sine power, say 9x dx. Now, the difference you observe with the previous exercise is power is odd. 9. In the previous one, power was even, but it will begin in the same way, n minus 1. So 9 minus 1 by n is 9, into 9 minus 3 by 9 minus 2, this into 9 minus 5 by 9 minus 4, this into 9 minus 7 by 9 minus 6. It cannot be 9 minus 9 because it will become 0. Therefore, into finally, since the power is odd here, I have to multiply 1 last, not pi by 2. And this becomes here 8 by 9 into 6 by 7 into 4 by 5 into, this is 2 by 3. And again, I will pause for a while and kindly solve this and get the answer. Here goes 3 once, 3 twice. And thus we have numerator 8 into 2, 16, 16 into 4, 64, into 2, 128 upon, this is here 9 into 7, 63, and 63 into 5. 5 3s are 15, 1 carry, 5 6 are 30 and 1. So 350. So this is the answer. So kindly go through the examples and understand. Here I would like to explain the third example. Please observe the video carefully. If I have integration from 0 to pi by 2, say, but if I have cos function, power I will take 6 dx, say, cos power 6x dx, power is even. Therefore, our answer is n is 6 minus 1 by n is 6 into 6 minus, this is 3 by 6 minus 2 into 6 minus 5 by 6 minus 4 into finally there is pi by 2. Why? Because this n 6 is even, or this number is 5 by 6 into, this is 3 by 4 we have, and next is half 1 by 2 into 5 by 2, and this product, so 3 goes here in 6, 2 times. Therefore, numerator we have just 5 pi. Denominator 2 into 4 8, 8 into 2 16, 16 into 2 say 32. And I will take up one more exercise or example. Look at this. Integration from 0 to pi by 2. I will take up cos power 7x dx. So here what we observe, n is odd here, 7. Therefore this answer should be 7 minus 1 by 7 into 7 minus 3 by 7 minus 2 into 7 minus 5 by 7 minus 4 and into 1 because n is odd here. Therefore this ratio becomes 6 by 7 into 4 by 5. 4 by 5. This into 2 by 3. Hence, 3 goes here in 6 twice. 2 into 4, 8 into 2, 16 divided by 7 into 5, 35. So, 16 by 35 is the answer. So, I have given one example each to each of the reduction formulae. I hope with this example, you have understood the reduction formula. Of course, I will take up a few exercises from the earlier competitive exams. So, dear students, here is a question using reduction formula. That is integration from 0 to pi by 8, not pi by 2. Cos power 4, 4 theta d theta is equal to. These are the options. Pause your video for a while and solve this on your own. Now, in fact, this exercise doesn't come straight away under reduction formula because upper limit is pi by 8, whereas we need pi by 2. Moreover, this is also 4 theta. We don't have theta, so nothing to worry. So first we apply method of substitution. See, I will begin here. We shall put 4 theta is equal to t. We make a substitution in place of 4 theta, which is t. And I differentiate this with respect to theta. Say 4 into, this is 1 d by d theta of theta 1. This is dt by d theta. Therefore, I need d theta, which is 1 by 4 dt. So these are the two changes. This is one change. This is the first change. Also, there is a change in limits of integration. So when theta is earlier lower limit 0. So when theta is 0, our t, let us see what is t. T is 4 into theta. So 4 into 0 is 0 itself. Therefore, new lower limit. See, if I call the integral as I, new lower limit is 0. And when our theta is earlier upper limit, say pi by 8. Pi by 8. T is 4 into theta. 4 into pi by 8, which is pi by 2 over here. Thus we get upper limit pi by 2. And coming back to the integrand, cos function same, power 4 same, but 4 theta is t. This is t, and d theta, see 1 by 4 into dt. Thus 1 by 4 out, this 1 by 4 out, and to this apply the reduction formula which I had given already, and the power is even. Therefore, it should begin with 4 minus 1 by 4 into 4 minus 3 by 4 minus 2 into then pi by 2 to wind it up. Therefore, this becomes, say now purely in mind work, 3 by 4, this is 1 by 2. So 3 by 4 into 1 by 2 is 3 by 8. There is 4 outside. So 3 by 32 and one more 2. So 3 pi by 64 is our answer. Hence, to this question, my dear students, option C is correct. So option C is correct. So this type of questions can be asked in the competitive exams such as CET, Comet K, etc. from this reduction formulae. So observe the video carefully. So dear students, here is second short trick in the same video I would like to mention. Say, if I suffix n, one integral is given, which is integration from 0 to upper limit pi by 4 tan power n x dx, then this answer, please commit to memory, I suffix n plus I suffix n minus 2 is always equal to 1 upon n minus 1. So this is the short trick. I will repeat. If I suffix n, this number n, they will give in the question is integration from 0 to pi by 4, not pi by 2, tan power nx. It is not sine power nx, not cos power nx. Then I suffix n, same integral, plus I suffix n minus 2. So this is our answer. By the way, I will show you how to remember this answer easily. In the rough work side, I write something. See, look at this suffix n, add to this suffix n minus 2 and divide by 2. That is, take the average. So n plus n, 2n by 2 is n, minus 2 by 2 minus 1. So reciprocal of this is our answer. Or I would like to give another formula in this only. So if I suffix n is equal to integration from, same question, same, 0 to pi by 4 tan power nx dx, then kindly memorize this in a similar way. I suffix n minus 1 plus I suffix n plus 1. See, one can do it as mind work. Say this suffix n minus 1, add it to this suffix n plus 1, divide by 2. So n plus n, 2n by 2n, minus 1 plus 1 cancelled. So reciprocal of that n, I mean 1 by n, is our answer. So therefore, my short trick second, in this there are two formulae. These I request you commit to memory so that you can save time in the CET exam. Now you may have a doubt that how it is possible that it is integration from 0 to pi by 4 tan power nx dx, then I suffix n plus I suffix n minus 2 is just 1 by n minus 1. See, without these limits, just integral of tan power nx dx, find I suffix n plus I suffix n minus 2. I have done a video in indefinite integrals. That video, if you can kindly go through, then just in that answer, in fact, that answer will be tan power n minus 1 x by n minus 1. You put the limits, you will get this as the answer. Therefore, watch the video carefully. This is my short trick second. Dear students, here is a question from Kcet. See, if I suffix n is equal to integration from 0 to pi by 4 tan power nx dx, where n is a positive integer, then find out I suffix 10 plus I suffix 8. So I will pause the video for a while and you people kindly solve this sum. Okay, I hope you got the answer. Here we have, look at the short trick. Suffix 8 we have 8 plus this suffix 10 divide by 2. Therefore, it is 18 by 2, 9. So, 9 is not the answer. Don't think option A is correct. Instead, reciprocal of 9, that is 1 by 9. Therefore, the given integral I suffix 10 plus I suffix 8, answer is 1 by 9. That is found in option D. Therefore, this question, option D is correct. So, the short trick, what I explained just now, that is, if I suffix n is equal to integration from 0 to pi by 4 tan power nx dx, then I suffix n plus I suffix n minus 2 is equal to, I said add n to n minus 2. So 2n minus 2 divide by 2. 2n by 2, n minus 2 by 2 is n minus 1. It's reciprocal. So 1 by n minus 1. That trick I have applied. Say add the suffixes 10 and 8, divide by 2, 9. But it's reciprocal. 1 by 9 is our answer. So kindly go through. Here is the next Kcet question. If I suffix n is equal to integration from 0 to pi by 4 tan power nx dx, then n into I suffix n minus 1 plus I suffix n plus 1 is equal to. Pause the video for a while and solve on your own. Okay, fine. I hope you used the same short trick, and I will explain again this short trick. Say take this suffix n minus 1 and this suffix n plus 1. Add both n minus 1 plus n plus 1. Divide by 2. So minus 1 plus 1 cancelled. 2n by 2 is n. But it's reciprocal. We need reciprocal. Reciprocal is 1 by n. Or in other words, if I have to find only I suffix n minus 1 plus I suffix n plus 1, then my answer is 1 by n. But see the question properly. They have cross multiplied this n. Therefore, in case I cross multiply n to the LHS, left hand side, my answer remaining is just this numerator 1, which is found in option A. Therefore, this question, option A is correct. Kindly go through the solution. Dear students, I would like to introduce short trick 3. Very useful one. Say, if I suffix n integral is equal to integration from 0 to pi by 2, same. Now again pi by 2. Sine square of nx divide by sine x dx. Then always remember, whenever we need to find I suffix n minus I suffix n minus 1, your answer is 1 over 2n minus 1. So what is the idea behind this? That is, identify this n and multiply it by 2. You will get 2n. Subtract 1. So 2n minus 1. Take reciprocal. So 1 by 2n minus 1 is your answer. So the trick is, if I suffix n equal to integration from 0 to pi by 2, upper limit, not pi by 4, sine square of, here nx, same n here, by sin x dx. Then I suffix n minus I suffix n minus 1 is equal to 1 by 2n minus 1. In fact, I will tell you briefly the method. I suffix n minus I suffix n minus 1 means it is integration from, see, the method, whereas you have to commit to memory this as a short trick. But if anybody is interested in, quickly, I will go through this method. This means integration from 0 to pi by 2. See, I suffix n, this integral itself, sine square nx divided by sin x dx minus integration from 0 to pi by 2, I suffix n minus 1 means, but sine square of n minus 1 into x by sin x dx. Hence, this will come under single integral notation, and there will be sin x LCM. Sin x. Numerator is this sine square nx minus this sine square of n minus 1 into x dx. And this numerator looks like sine square a minus sine square b formula. So it's integration from 0 to pi by 2. Say sine square a minus sine square b is sine of a plus b. A is nx plus b is n minus 1x. N minus 1 into x into sine of a minus b. A is nx minus b is n minus 1 into x divided by, there is a sine x as it is dx. Therefore it is integration from 0 to pi by 2. Now if you do mind work, nx plus nx, 2nx. So sine of, this is 2nx and this is just minus x remaining. Whereas this is nx minus nx gets cancelled, and minus into minus plus x. So sine x divided by same sine x dx, and this sine x thus cancelled, and what remaining is within the integral symbol, integration from 0 to pi by 2, say sine of 2n minus 1 in bracket x common dx, and this integration is minus of cos of 2n minus 1 into x divided by differentiation of 2n minus 1 x is 2n minus 1. Calculate between the limits 0 and pi by 2. Thus, this is easy. This you can manage on your own, and this answer will come out 1 by 2n minus 1. But when it comes to CET and competitive exams like Kcet, JEE Mains, etc., I request you commit to memory this as a short trick. Watch the video carefully. So dear students, here is an exercise. If I suffix n is equal to integration from 0 to pi by 2 sine square nx by sin x dx, then I suffix 8 minus I suffix 7 is equal to. So here, with the students, use short trick 3. N is this 8. Therefore, I said answer is I suffix 8 minus I suffix 7 is 1 over 2 times n is this 8. 8 minus 1. Therefore, 1 by 16 minus 1. 1 by 15. Therefore, option B is correct. Hence, this exercise, option B is correct. Kindly go through the solution. Students, here I have written 2 more short tricks. Kindly go through them. Say, short trick 4 says, if I suffix n is equal to integration from 0 to pi by 2, x power n sin x dx, then I suffix n plus n into n minus 1, I suffix n minus 2 is equal to n into pi by 2 power n minus 1. For all n greater than or equal to 2, this is true. And to get the proof of this done, you please apply integration by parts rule 2 times. So for that you can watch my indefinite integrals video. And short trick 5 is, if I suffix n is equal to integration from 0 to pi by 2 x power n cos x dx, instead of sin x we have cos x, then question is same, I suffix n plus n into n minus 1, I suffix n minus 2. Answer is pi by 2 whole power n. So kindly go through the video carefully, pause for a while, commit to memory, study this. And I would like to mention, using both these short tricks 4 and 5, till now no CET questions or commit questions appeared, but it is better you know these formulae as short tricks. Watch the video carefully.